Hey guys, so today's topic is average atomic mass. Now, I'm not going to take the time to spend reading this whole part for you because you can do that on your own. But what I need to have you understand is that we've actually already been talking about this number a lot in class, and now it's time to figure out where it came from. So if you'll notice, one of the first words in the first sentences is isotopes. And in that respect, you will have an average atomic mass if you have an isotope. So if you remember and recall the decimal number on the periodic table, if you were looking at your periodic table right now, almost every element on the periodic table has a decimal number. Well, that decimal number is the average atomic mass of that element. And what it means is it has either 1, 2, or however many more different types of atoms for that element in respect to differing number of neutrons. So remember, an isotope has a different number of neutrons than what is seen on the periodic table. So when we talk about the next step, let's do a real quick review and make sure that we understand where all these numbers and words are coming from. So I'm going to go over to here and we're going to talk about what this all looks like on the periodic table. Okay, so if you have a tile, and yes, I'm wearing gloves because my fingernails are hideous. So here's your periodic table tile, aluminum. 26.982. Okay, so this 26.982 is our average atomic mass. Well, before we were rounding this. When we rounded that, so if I move this a little, you're going to notice that that's the atomic number, like we talked about before, number of protons, and this is my average atomic mass. Okay, well, when we rounded it, it became known as our mass number, which is the number of protons and neutrons. So, when we write it into an equation form, it looks something like this. So now we have 2713 aluminum. So this mass of 27, subtract 13 from that, and you get your number of neutrons. Now, where did this number come from? We know that 27 is rounded 26.982, but where did the 26.982 come from? Well, in life here on Earth, there are 3 naturally occurring isotopes of aluminum. We have aluminum 26, 27, and 28. Okay, so if I were to give you this problem, you could do this without doing any math, believe it or not. It says, without doing any math, which isotope has the greatest abundance? Well, you can't tell from just looking at these numbers. What you have to look at is the actual periodic table tile that we were just talking about. Notice that aluminum is 26.98. We already know if we round that number, it rounds to 27. So the element here, or the atom there that has the greatest abundance here on Earth is aluminum 27. So this number has a relationship to each atom in respect to the greatest abundance here on Earth. So if I move this back up and we talk about another example, okay? So, for example, we were talking about what does all of this mean? Well, here it is. Average atomic mass is the weighted average of all the masses of naturally occurring isotopes of an element. So in the worksheet that I just showed you a few seconds ago, it mentions carbon-12 and carbon-13. There are many isotopes of carbon, even 14, that's not mentioned on the paper. And all of those come up to determine that decimal number on the periodic table. Well, so if I go back to this problem and I show it to you, we scroll down a little bit, we're going to go to do some practice problems. Okay, well on these practice problems it says, be sure to show all your work and don't forget units. Okay, sig figs are challenging with percentages and so we don't use them here. You're welcome. Okay, so in that case, all you're going to worry about is making sure that you show me your work. And how do you show me your work? You're going to have to type in this document or write your problems on a separate sheet of paper and then upload that picture to me so that I can see your work. Remember, it's easy to put an answer down. It's harder to show the work that got that answer. All right, so there's 2 examples I'm going to work out for you. The first one is written there and then the second one is here. They're both on the worksheet, so you'll have them to be able to look over them as well. So the first one, I'm going to read it to you and then we're going to flip back over to the problem. So it says rubidium is a soft silvery white metal that has 2 common isotopes, 85 and 87 rubidium. if the abundance of rubidium 85 is 72.2% and the abundance of rubidium 87 is 27.8%, what is the average atomic mass of rubidium? Okay, so as always, word problems. What's important? Notice the most important thing here is that you all know, hopefully, that percent means out of 100, so percent per 100. So this number and this number should add up to 100, and they do, or they should get close to 100. Okay, and in that respect, you know that we were talking about the right number of percentages. Now, what does your answer need to be between? Your answer should be between 85 and 87. If your answer is nowhere between these two numbers, sorry guys, then something's wrong. You've done something wrong in your problem. And if that happens, we need to start over. So here we see the same problem that's in the paper. So it says, what is the average atomic mass of rubidium if you have two isotopes of their respective abundances are these numbers? So here are your steps. Your first step is to take the percentage and put it into a decimal. Okay, so now if you'll recall, this is again out of 100. So how many zeros are in 100? 2. So move it over 2 decimal places and you'll get if I can take the numbers out, 0.722. And then you'll do the same thing for rubidium 87. So 27.8% is 0.278. Okay? Next, multiply each isotope by its abundance. So 85 multiplied by that number and 87 multiplied by that number. So I have it written down here, and this is where they came. So it looks something like this. 85 times the decimal number, 87 times the decimal number, and you get these two numbers. They're answers. Now, what do you do next part? Add your answers. So if you add the two answers that you got from multiplying the first section, you'll get 85.556. Okay, now, notice I've done no dividing. It says average. What is the average atomic mass? You are not dividing anywhere, so do not divide. You're basically done. The last step is to add units. So if you add your units are now called AMUs. So the answer becomes 85.556 AMUs. And an AMU is an atomic mass unit. So now notice I told you guys your answer would be correct if you had it between 85 and 87. My number is between 85 and 87, so it is correct. And what I would suggest is noticing also that 85.556 is closest to 85 rubidium, right? So because of that, clearly we had a higher percent abundance of rubidium 85 than we did 87. So all of our answers and everything checks out. Okay, stay tuned for number 2 of teacher examples.